Wow, it feels freezing outside, but the puddles are still liquid. Well, you know what I mean. Ooh. I wonder what the temperature is and what the temperature would actually have to be for it to freeze. I'll check the weather on the internet. Let's see. Right now, the temperature is 3 degrees Celsius and it's also pretty windy. Look at the next few hours. A cold front must be moving in. See the predicted temperature dropping? The forecast is changing too. Can you tell what the freezing point of water might be by looking at the chart? Did you notice that at 7 p.m., the precipitation is predicted to change from rain, which is a liquid, to sleet, which is ice? Everything above the zero in the chart shows liquid water, rain. Once the temperature hits 0 degrees Celsius, then falls below zero down to -6 degrees Celsius, the forecast changes to ice or snow. If you thought that 0 degrees Celsius was the freezing point of water, you're absolutely right. Did you know that 0 degrees Celsius is also known as the melting point of water? This is the point where water can change state between liquid and solid. When pure water that is losing heat energy gets to 0 degrees, it changes from liquid to solid, and we call that freezing. What if there's snow tonight and the weather warms back up tomorrow? The water will gain heat energy from the sun, and when it gets to 0 degrees Celsius, it'll melt from snow back into liquid water. So it looks like both the melting and freezing point of water is 0 degrees Celsius, and what we call it depends on whether the water is gaining or losing heat energy. Looks like junior scientist Jess is wondering what happens if you melt ice into water and then keep heating it. Let's test that with an experiment. First, we'll start with some frozen water and add heat energy using this burner. We can continue to add heat and record the temperature to find out what the boiling point of water is. We'll use this thermometer to measure the temperature of the water as we add heat. The thermometer uses the Celsius scale. Do you see the freezing and melting point of water? Here it is, 0 degrees Celsius. Well, I've got my materials and my safety equipment ready, so let's start. First, let's see what the temperature of the ice is and record our starting point. Well, we had to wait a while, but the temperature of the ice when we first started was 2 degrees below zero, and it was a solid. I'll be sure to write this down in my notebook. We'll read the temperature every 2 minutes. Unless we see a really big change in between readings. That was fast. See the ice beginning to melt? Let's check the temperature now. I'm going to put a star here because 0 degrees Celsius is the melting point of water. That's an important number to remember for melting and freezing points. As we continue adding heat to the water, the rest of the ice melts and we're left with only liquid water in the beaker. The solid has completely changed to a liquid, and the little bubbles forming at the bottom of the beaker tell me that it's beginning to turn into a gas. You can see from our data that the temperature is increasing inside of the beaker. Yep, 98 degrees. The evaporation coming off the water shows us that the water is very close to its boiling point, 100 degrees Celsius. There you go. We've reached the boiling point and this water vapor is hot. I'll put another star by 100 degrees Celsius since it's the boiling point of water. I guess that answers Jess's question. Let's review. When heat is added to or removed from water, it can change state. At 0 degrees, water changes between solid and liquid by freezing or melting. At 100 degrees Celsius, water changes between liquid and gas by either evaporating when it boils or condensing as it loses heat. I have been wondering though, I've read that melting and boiling points of water can be changed by adding something to the water which changes its physical properties, like salt. What would be the freezing, melting, and boiling points for ocean water? I bet they'd be different from the ones for pure water.